Hello everyone. Our team name is Sky Harvest and our problem statement focus on machine learning. So our problem statement is farmers facing delay and
Tell us,
inaccuracy
tell
in
us. ఇది
accessing
அப்படியே
crop damage
మర్చిపోయి
after
పోடுறாలే
natural
అందరూ
disaster, which harms their ability to claim subsidies. Manual inspections are slow, inefficient and often inaccurate, causing financial strain and delayed recovery. There is a need for faster and more accurate damage assessment to streamline subsidiary claims. So our proposed idea is using drone to capture the images of disaster affected farms and then give it to the machine learning algorithm, and it analyzes the damage and generate a report to the help farmers quickly claim their government subsidies. This ensures the fast and accurate damage evaluation and speed up the subsidies process.
గవర్నమెంట్
It
ల్యాప్టాప్
also
ఫాస్ట్
helpful
అక్క
for the government agency to
అదేం గప్ప
fast up their process in giving the subsidies. So the overall title for our project is Advanced Drone Based Assessment for
యారు పని కొడుతా
Agricultural
ప్రాజెక్ట్ అక్కడ
Losses
ఇంటిలే
and Government Subsidies Automation. So let's dive deep into the problem statement. Farmers experiencing a natural disaster such as flood, droughts, hailstone, and the pest investigate, often struggling to accurately assess the agricultural losses. Current manual inspection methods are slow, sometimes it causes the error, and lack real time insights, and resulting in inadequate compensation and delayed government subsidies claims. There is a critical need for a faster and more accurate system to evaluate the agricultural damages and, of course, to streamline the process of getting subsidies with the report from the survey. So our overview is like farmers face insufficient challenges in recovery from the natural disasters like flood, droughts, and pest investigation, and which deficit the crops and lands. The current damage assessment and subsidy claim process is slow, inaccurate, and relied on a manual inspection, delay compensation, and threatening the farmers' livelihood, which leads to the farmers' protest in various states and opposing the governmental policies. Even though the governments are doing good in their process, this kind of inaccurate and slow process have a hurt mindset in farmers and which lead to a protest in the later time. So, a technology driven solution is needed to assess the agricultural damage efficiently and streamline the subsidy claims, ensuring timely and fair compensation. So, whatever the what the our problem is briefly explain about the problem faced by the farmers or in the Department of Agricultural damage after disasters, leading to delay and inaccurate in claiming subsidies. So, our technology driven solution afford real time damage assessment and streamline the subsidy claim process, ensuring the timely and fair compensation to the enhanced farmers' realization against the future disaster. So, our solution is first cover the data analysis and prediction. Machine learning algorithm analyze the history and the real time data to identify patterns and predict the extent of agriculture damage caused by the natural disaster. This helps in creating accurate assessment that reflects the true impact on crops and lands. Second thing is automated damage classification. Machine learning models can automatically classify the severity of damages based on the various input parameters such as satellite imagery and the sensor data. This automation reduces the need for manual inspection and speed up the assessment process. Finally, continuous improvement. As our data is collected over time, machine learning models can be continuously trained and improved, enhancing their accuracy and effectiveness in predicting agriculture damages. This iterative learning process ensures that farmers receive increasingly precise assessment and compensation recommendations. Next thing is that tech stack. We are using YOLO v5 as our base model and Python for our languaging, and we use several CNN models. And now we start with the central scheme alignment. So first of all, we talk about the Nemo drone DD. This is initiative empowers the women through self-help groups by providing a drone operation training. Our system can leverage this to enhance the local drone usages, promoting gender equality in agriculture assessment. Second thing is that SMAM department, submission on agriculture mechanization. By integrating with SMAM, we can ensure the farmers has access to necessary software and hardware support for the drone, improving their efficiency in damage assessment and subsidy claims. Third is the digital agriculture mission, which is DAM. This scheme allows us to store and publicly access the report generated from the drone assessment, facilitating transparency and better decision making in agriculture department. Fourth thing is that national e-governance plans in agriculture. Our system can improve pre-disaster planning by providing data that helps agriculture technology management agencies, which is ATMA, implemented effective disaster mitigating strategies. Finally, the Ministry of Department of Agriculture and Farmers Welfare. The ministry can utilize our data and our system to improve the planning and decision making during and pre and post
Five
disaster
minutes
event,
ago.
enhancing overall disaster management. And the benefit to the
Namaste.
stakeholders, as we discussed, our system
Right side, na?
provide a structured and well-defined
Mat.
data. This data is generated will be crucial for state agriculture department as other insurance companies which are tied up with the subsidies projects in central government, ensuring timely compensation for the farmers under government subsidies schemes. Additionally, our system will provide valuable insight to the National Disaster Management Authority, which is NDMA, for better disaster response planning. Let's talk about the dependencies. For this project, we utilize several key dependencies to build a compensation system for analyzing drone data, generating PDF reports, and integrating plant health assessment using YOLO V5 as a base model and as a backbone architecture. The primary library we use is FPDF, which is used to create a structured and formatted PDF reports, and a Faker to generate a synthetic data such as location, data, and recommended values for testing purpose. For plant health classification and land assessment, we incorporated with YOLO V5 model, which leverages the PyTorch for machine learning, allow real-time object detection and plant health monitoring. Additionally, OpenCV was used for image processing, enabling efficient handling of image captured by the drone, recommended for the data test and achieved by random, and NumPy was employed for the data manipulation and
Construct.
numerical operation. This dependencies together facilitate a streamlined process for data collection via drone to implant health classification and the generation of detailed PDF report during pre and after disaster management. So, in terms of additional info, this is our entire flow. Let's start with the farmland. We will check for the affected farmland and we will take the survey using drones and we will submit a reported which have the entire document what are the damages happened in the land and what percentage of damages happened in the land and what will be the available opportunities to improve the land in a detailed format PDF reports, and we will submit to the bank allocating compensation, which is the especially the government,
Seven
and the
minutes
government sending the drone for survey, which is also effective for drone. So the detailed reported will be submitted to the government, and the government will
7:30
be able
na.
to make the decision very fastly to allocate the funding to the
7:15.
farmers.
Next
So
way forward.
basically, the flow goes like data collection and our ML model and our software and PDF reporting, synthetic data generation, image processing. In terms of future enhancement, we are ready to collaborate with the government agency, which will be very effective for developing the agriculture in terms of leveraging technologies. And this impact aims to empower the farmers and agriculture businesses with actionable insight to improve crop yield, optimized resource usages, and enhance the overall farm management. Finally, this is our teammates, and we have worked together, and we have the base knowledge about drone, and we have completed the certification from central government, which is a drone assembly and technician management services. So myself, Ashwin. So I'm expert in ML